All of you, and today is the last day of our workshop, or I can say course. So fifth day, and we are starting lecture number 13.
Yes.
Lecture number 13, and it is about the overview of ancillary services requirement for the grid integration of green hydrogen energy systems. Okay, it will be delivered by Professor Jahangir. Over to you, Professor.
And good morning, everyone. So, the first lecture, what I'm going to explain, I mean, although we did explain, like, what actually mean by ancillary service, why we need pay more attention to deliver ancillary service to the grid with renewable energy, and most importantly with green hydrogen system. And then we can also talk about that how ancillary service is evolving, and then finally I am going to show a few examples to show the potential of ancillary service that can be delivered by green hydrogen system. Now, all of you already know that what actually we expect from power system, or as a engineer, if you want to design power system, I mean, what are the different aspects that we need to consider while we are designing, while we are operating the power system. So, as you know that, I mean, we talked many times that we need to decarbonize the power network, because this is one of the major contributor to greenhouse gas emission, and that is why most country including Australia, India, now they are phasing out the fossil fuel power system, which is mainly comes from coal, gas and so on, by replacing with renewable energy renewable energy. Second requirement is that the system has to be reliable and resilient. So, the reliable and resilient means that we expect service 24/7. That means there will be no blackout, no outage of power supply. So, we expect continuous supply from the power system. That is mean reliable. Other requirement that it has to be very high quality. The power quality should be very high, and again as I mentioned like that, power quality means we expect the current voltage waveform should be exactly sine wave, right. So, if it is not exactly sine wave, that means we do have power quality problem. And also when we have got voltage frequency outside of the acceptable range, that also mean like that our power quality is not very high, and even that requirement is getting very tight with large scale renewables, and also when the system is operating very close to his maximum limit. So, for example, a transmission line has got, for example, capability, let us say 20 megawatt, and it is operating and transmitting power close to that limit. And then as you know that, the demand for electricity uses is going significantly as we are electrifying all other different sector, which are now either run by gas or other fuels. So, now we are moving more like electrified, even like the electric vehicle and so on. So, the demand is growing. So, we have to make sure that our system also upgrading, and at the same time also we did mention that it has to be economic, but as you know that it is having the sector coupling with other sector, for example, transportation, communication and so on. And again also I mean it has to be like universal. We are not only considering like few countries. So, we have to make sure that people from all around the world, they do have access for that electricity, and most importantly that it has to be affordable. So, that's like the I mean more important even people in developing country where they have got like an economic constraint. So, those are the all things I mean we need to ensure, and to ensure that in many of the cases I mean that ancillary service can actually play a significant role to meet the goal that I mean power system has, I mean to supply power for the whole humanity. Now, also we already talked about that while we are having large scale renewables either Australia, India or any other country, it is good that I mean it is contributing to decarbonize the sector, but at the same time it is also introducing new problem and new problems mainly again in terms of power quality, voltage imbalance, grid stability and reliability. And again to address that issue, we need to get like an ancillary service from different inverter converters that use renewable energy in hydrogen in and also I mean other storage like batteries. So, they actually should provide ancillary service to give that power quality requirement. Now, we like already talked about many times that is here if like our frequency is 50 hertz exactly like this, right, that means our system does not have any problem, right. So, that means our generation, our demand are matching each other, right. But if it goes either left or right, that means we do have problem, right. And then I mean we need to find out the ancillary service that we can get for any of the devices. And here many of the things that you can see like photovoltaic system, fuel cell, wind turbine, many of the things can contribute to move that one either left or right. So, this is like again already I mean maintaining balance on a sometime difficult, but due to this all this technology even it is making to harder to keep that instantaneous balance between supply and demand. But still I mean power system is inherently actually stable, because you see we always I mean turning on and off the load, right. That means the demand is changing, but the system has got the capability to quickly make these things balance, considering all the control, all the monitoring system we have. So, inherently is stable, but again I mean in nowadays I mean you see the frequency of blackout is actually getting higher due to like not only large scale renewables, but also frequent severe weather events. So, yeah I mean why we need that, I mean we already talked about the ancillary service does help to manage the fluctuation in power demand as well as supply, which preventing like grid disturbance and ensuring like reliable flow of electricity. It does help to maintain the power quality, that means the voltage and frequency within limit. Ancillary service, that is also like very important to I mean integrate large scale renewables like wind and solar, and also like even like if there is a outage, that case also ancillary service like black start capability that help to restore the grid and reduces the downtime of the grid. Again, I mean, there are like plenty of different option that can help to integrate that variable large scale renewables, and here like number of example provided. So, it could be like that we have got very enhanced grid operation, other improved operation like different forecasting technique that I mentioned yesterday. And enhancing grid means like either transmission, I mean having new transmission expansion, or you are installing new devices like fax devices. Flexible operation, that is also actually quite important, and we did mention that like once we have got those different control load, and one of the example that I provided, that electrolyzer. So, when you can control many devices in the system, that means your system has got more flexibility, and once you have got more option, then it is easy to run any system, even like the power system, right. So, even if you are organizing any like company or any industry, you have like more flexibility in terms of the people, in terms of the whatever devices you have in the system, then it would be more easy to run that system, same like in the power system as well. And then demand response, storage, and although all of these things like renewable are variable, but once you have got very accurate forecasting, actually you can address that variability option, because you already know what is coming ahead and you can just prepare based on that. And storage, previously we did have only few option, but now we have having more option once we have got the hydrogen as well. So, that also helping to provide that service to the grid. Now, in Australia, we have the organization which is called Australian Electricity Market Operator. They are the person who is responsible for ensuring that ancillary service to make the system like more secure, more safe, and also reliable. And like in Australia, I think I found like even I think in India, I am not sure, I might be wrong, but they say like that in India you have like grid controller or India Limited, which is probably responsible for maintaining the grid stability and reliability. So, they might be the person who are providing ancillary service, and in Australia I already mentioned. So, they actually mention and monitor that voltage, frequency, waveform quality, phase balance, everything are within the acceptable limit. If not, they are going to go to that ancillary service market and buy that operation to make sure that everything within the grid code and within their desirable range. Now, when we are talking about like that ancillary service, it's like a set of operation, it's not like a single thing. It's beyond like basic generation, transmission, and distribution, and that mainly essential for maintaining the reliability and stability. And here you can see there are so many example of ancillary service. For example, we even like in the literature they classify into two different types. One is frequency, another is non-frequency, and the frequency could be like fast frequency range, frequency control, regulator, fast if frequency regulation, sorry I forgot it, but it's actually in the slide, but it's everything relevant to the frequency service to maintain that 50 Hz that I mentioned. And then the non-frequency, it could be like related to the voltage, voltage regulation, reactive power service, and then other operating service could be that you have got that spinning reserve. You know, if something happen, I mean, we could use the reserve service, and there are also like a non spinning reserve as well. And again, the other things that I also mentioned, like that black start capability, that also, like, you know, sometime it consider under the under like the ancillary service here as well. So here things that I mentioned, sorry, that's like the things. First, frequency response, which is FFR. First, I mean, frequency containment service, which is FCR. That's I mentioned like in the previous slide, FCR. And then frequency restoration reserve, that FRR. So that's all, and even the inertia response, that's also relevant to the frequency. And then for voltage support, reactive power support, black start also, like, which is called, I mean, could be like a system restoration and different spinning service. But at what time frame you should provide what service, that also very, very important, right. For example, you see the inertia response, first frequency, all are in the second, like, so it has to be very fast. When it's changing the frequency, whatever service is going to be, you need to provide, like, you know, second to minute. So it will be like a fraction of minute. And then that is spinning service and other things that might be in the hour, reactive power and black start, that could be like in an hour to days. So whatever service you are planning, you have to make sure that you are, you know, providing that service considering the time frame that it needs. Because if there is a fast frequency problem and you are planning to supply, like, you know, in maybe, you know, tens of minutes, by that time system will be already unstable. So you have to act very fast. And some of them, like, already, again, I mean, this is that either automatic or manual, because that's already changing, right. Some of them, like, you know, many of them might be automatic few years back, but every country now they are, you know, trying to go for, like, you know, that is smart grid, where everything people are trying to make it automated. So some of them are already automated, some of them even not now, but it might be automated. And if it's automated, you see that time is quite fast. So again, most of the cases, like, you know, either in second or even like the fraction of second, like the inertia, virtual inertia, and some of them, I mean, if it is manual, then you expect that it will be slightly like, you know, delayed service. Like here you can see, like, it is in the range of like a minute, which is like the manual. If you want to replace something manually, then definitely is going to take some time. But these are the different service, and this is the, you know, explanation of that, whether it's automatic or manual and what's the time frame. And the purpose I already mentioned, like, you know, to maintain the frequency and, you know, stability. Now this I'm just showing, like, for example, let's say you have a power network and there is a outage for some reason, either external fault or internal fault. Then what happen, like, your frequency gonna go down, right. And then, as you mentioned in previous slide, we have got number of action we take to bring the frequency back to 50 hertz, right. So again, I mean, here you see that, I mean, initially within few seconds we take some measure, and then if not, then we also have, like, you know, other following service that gonna we apply to make sure that frequency go back to the previous condition. And here normally we call like the primary frequency control, secondary frequency control, and then we have got tertiary frequency control as well. Like one of them, the first one responsibility to make quickly back to the close, and then the following one to precisely making like 50 Hz. So, for example, let us say it go like from 50 to 48, then we bring like close to 50, for example, let us say 49.5, and then the top level controller, they are trying to bring it precisely to 50 Hz. Like we already mentioned, like the supply and demand to make for the frequency control. Now, in Australia, I mean we have got mainly that service are initially provided by AGC, you know, that automatic generation control. I think in India also quite same. In most country, I mean initial service are provided that on automatic gain control, and as I said that and that control also have like, you know, monitoring to see that, I mean the frequency whether within that range or not, and the normal operating band at all this is the range that, you know, MO always monitor and make sure that the frequency is within that limit. And how they actually do that service, again, I mean as I say, like, you know, they monitor, and then when like, you know, it change goes outside, they send that control signal to those like, you know, devices which provide ancillary service, and again check, if not then and then this is like a closed loop, and that is how actually they you know, do that frequency control service. And this is not only Australia, I think this done in India and other country as well. So, that is the like, you know, AGC, but other one also, I mean as I showed in the previous slide, that contingency frequency control, which mainly you know, correct the supply demand following a major contingency effect, for example, like a loss of generating unit, major industrial load, or large transmission event follow. But if like something small changes, AGC automatic gain control by automatically, I mean it can reach to the frequency, but this one will come into picture when you have got like, you know, very major event which will take the frequency far away from the 50 Hz, and in that case, I mean we need this sort of you know, service. So, again, I mean this is the time frame when you have got this contingency frequency control, that is how you know, operate. So, if you have like, you know, very fast I mean either, you know, going down or going up, they apply that service, and then you know, expect that it again, I mean slowly come back close to the, I mean 50 Hz. And as I say, like, you know, even if not 50 Hz, if one of the control cannot, then the top level control like, you know, secondary, tertiary, it will bring back to in the 50 Hz or close to 50 Hz. And there are that contingency frequency control that can be done in you know, not providing only single service. So, definitely it gonna coming from your generator. If generator not enough, you might have some load shedding, that, you know, you are cutting some of the load for balancing it. And also, I mean whatever the spinning reserve we mentioned, that you can have some, you know, generator which has got rapid service, you can also bring back to the system to increase the supply, so that it can be you know, matching with the demand. So, there are, I mean number of, we actually we do provide that I mean emergency I mean frequency control service, and that, I mean regulation up or regulation down, I already mentioned that either it can drop or it can rise depending on, I mean if you have got generation outage and you know, your demand is higher than the generation, frequency will go down, and if generation is higher than the demand, frequency will go up. And again, I mean this is just showing, I mean different time frame, where I mean those first raise of the frequency, if there is a drop, I mean we did mention provided in the frequency market. So, this is like the time frame for Australian national electricity market, but again I mean it could be quite similar for Indian case as well. Yeah, that is true, I think I already mentioned. And then that is all about like the frequency. What about if you have got the non-frequency regulation service that you need? And one of the non-frequency is important one is the voltage regulation, and we did explain like why voltage stability occurs. And then I mean if it occurs, then I mean somehow we have to make sure that like frequency, which is like demand and generation, but that is real power generation, I mean real power and real power demand. But for voltages, the reactive power supply and reactive power demand, if these two are equal, then I mean you will have I mean your voltage is stable. Now, here many of the voltage like still like manual, but nowadays like OLTC and other things is getting like automatic as well. So, the fax devices, that is also I mean if you have they operate automatically, but still I mean like the black start and other things they done actually manually, because the system has got collapsed and it is not that automatically. Then the whoever the operator, they will see like which devices they should start first, and then gradually which load it will bring online. So, that is how I mean they actually do it manually, but at the same time definitely they check the system performance as well. And voltage like that instability, or you can say quality, that can happen in many different way. So, you have got like normal voltage, and then you might have voltage interruption, voltage sag, under voltage, over voltage, voltage fluctuation. So, it can happen actually in different ways, not only going outside of the limit, but that service can actually have I mean different types of problem. And again I mean based on the problem also I mean your solution would be different as well. For example, if you have got under voltage, it would be one solution. If you have got over voltage or voltage sag, voltage swell, I mean definitely I mean you need different sort of service. Now, for controlling the voltage, these are the like ancillary service. We have like voltage control ancillary service, network loading control ancillary service, and the last one it not exactly voltage, but it has got relation with the voltage, which is called transient and oscillatory stability ancillary service. Now, again I mean how that works. So, as you know that every generator, it has got automatic voltage regulator. So, when there is a change, generator try to absorb or generate reactive power to control the voltage, and as I mentioned that reactive power is managed actually to stabilize the network voltages. So, it can be done either normal generator also on top of that. It can be done with the like synchronous condenser, or even like compensating devices like the fax devices, and there are many example fax devices like STATCOM, SBC, which actually employ mainly controlled capacitor and reactor. The capacitor like that can supply reactive power, and inductor it can also absorb reactive power. So, most of the cases when you are talking about the fax devices, it is nothing but the combination of power electronics plus capacitor and inductor. but also many system in a network also you find synchronous condenser as well. And again also other things people are thinking that even in Australia, might be other country also thinking that when the normal generator retired from the system, because we are phasing out like the coals and other things. So, why not we use that normal synchronous generator as a synchronous condenser. So, that is not going to be producing power, but it can contribute to maintain the system stability and providing ancillary service. So, that is Australia, they are already thinking that if they are retired and still they have got lifetime they can use, they will keep that in the network just to provide the ancillary service, but not to provide any even not for very like long time, but still for few years, just to make sure that their system are like stable. And then the transient and oscillatory, it definitely helps transient, but at the same time as I said that it also helps the voltages and so on. And one of the established devices control that actually help, you might already know that power system stabilizer, PSS. People like when that we did not have the renewable generator, and that time power system research was almost like saturated. People are mostly working with PSS and then AVR, but after that when that renewables come, people are moving their research more to the renewable. But this is one of the devices that helps to improve the even like a small signal and transient stability, and this is a like a one of the major component of the synchronous generator. And other devices that also can help like that synchronous condenser I already mentioned, SVC, that also, and also the devices which provide inertia support, even like the synthetic inertia that we mentioned, that also help to improve and provide like that transient and oscillatory and ancillary services. And then we talked about that black start or system restoration, that is also you can think of like one sort of ancillary service as well. So, once we have that either partial or complete system blackout, then we need that restoration service, and we already talked about that when we have got the grid forming inverter in the system with the green hydrogen system, that can help even for the system restoration as well. And for system restoration definitely there are a number of stages. When we restore that one, so initially again you have to prepare and have proper plan how you gonna do the restoration. And for example, let us say if the whole Australian grid get blackout, whether they gonna which city they gonna bring first. So, there would be like a location wise also map that's how they gonna do. They will also plan which generator should be coming into the online first, and then how the other generator will bring as well. So, once they have plan, then they restart that affected system and restore network and supply to the major generator, because many of the generator also like at the starting you might need supply to magnetize. Sometime if you have got a synchronous generator, right, if it is like separately excited, then you have to excite the system first as well. And then as I say like how they are going to bring the restore the load, how they are going to bring the available generation, and then finally once they will also bring all the remaining customer transmission line, distribution line, everything online. So, this is like in brief, but definitely when they plan, they have got like definitely established plan, they actually follow to do that. Now, for like the green hydrogen, we already talked about like under what condition and how they can provide that ancillary services, and definitely also next lecture I am also going to talk about some standard they need to follow when they are connecting in the grid as well. And although they are not participating in the demand both demand response and other ancillary service, but definitely they are going to be participating in coming probably years. And once you can get ancillary service even like from green hydrogen and or others, there are like number of advantages, and one of them is that to delay the network upgradation service. So, for example, to delay the building new transmission line or distribution line. So, that like one of the major advantages when you can get ancillary service from the existing devices including hydrogen. So, this is like some of the existing project, like they are already doing experiment that whether hydrogen can provide ancillary service, and if like what sort of service. So, here you can see that number of them already like operational, few of them like in R&D phase, few of them like demo, some of them doing like feasibility study, but this is all real project, it is not like simulation. And this is some of the technology that they are using, and you see that most of them like PM, but they are using like others as well. And it is not only hydrogen, but you have got like other technology as well, other mostly like you see renewables, what the size of those like green hydrogen technology, and then what they are like end uses, what service they provide. So, all of them that I mentioned like an FCCR, FRR, grid balancing. So, and here also reference as well. So, in case if you want to go very deeper, like how like they are providing, and if you want to see some of the result that they already provided. So, what I am trying to say that it's not only idea, the technology is already available and some of them is already, but it's not like commercially providing, but once they say that it's like all the demonstrations successfully doing things, and at the end say that they find that this is also economically viable as well, because this is most of them their target to see that whether it's technically viable. But once it's done, then also you will do like economically viable as well, and once both of them are fine, definitely it gonna be providing great service to the grid as well. Although this is some of them, but as I said like we have got another class for standard, some of them for you already might know about those which is mainly using for renewable energy and also EMI and other things, but next class I am going to also talk about some of them as well. And for these are the some of the requirement, like in Australia they have already said that if someone want to integrate large scale electrolyzer or fuel cell, they have to do a several study and make sure that it can provide all these services, then they are going to be allowing to connect with the grid if it is a large scale application. And I believe in Australia also you will be having similar requirement, just to make sure that it comply with all the regulatory requirement. Not only sometime also what happen like you have got state level, but also sometime you have got the country level, but sometimes also have the state level requirement as well. So, I think in India also Australia we have got different state, and probably you know better than me that every state have got their like own rules and regulation as well. So, that also sometime we need to satisfy, and it is not only like those grid requirement, but also in terms of safety, hazard. There are also many standard that we need to follow while you are designing and implementing those green hydrogen system. And even like I do have experience, like even in our university we are trying to have a small kilowatt level experimental setup, and it took almost like year to have that lab ready, because they are also invited external expert. They come and check, because they have got very strict requirement, and I believe here also if you want to do that. So, that is why you have to start probably taking like at least 1 year time, that if you want to develop a good lab. So, again it is not like everything from my paper. Some of them I have taken from the literature. I do have like one example from my group as well. So, here like one of the case study done by the research group from NREL in USA. So, they are having like good setup to do both like hardware in loop experiment, and also the doing experiment with the comparatively small size system as well. So, they are doing both simulation as well as experiment, just to see like what sort of service they can provide, because although we are talking more generalized frequency and different type of stability, but it is not that every time you will be able to solve that problem using hydrogen. So, if something relevant to the demand side, the load, the electrolyzer, one of the example that you remember that I shown previously. So, that can actually provide good service, but let us say if some problem introduced by synchronous generator. For example, if you have got a small signal stability, in that case it is found that the electrolyzer, it cannot contribute to reduce the oscillation that is coming from the synchronous generator. So, that is why we need actually more research to find out exactly like if you have a system, if problems can happen in different area, right. So, it might be that something relevant to photovoltaic system, might be something from synchronous generator. So, it is not that if anything happen, you expect that the problem will be solved by the green hydrogen system. So, that is why we actually need to do like more studies, to see like what problem exactly it can solve and what problem it cannot solve. So, here they did simulation with that system, and if you want to parameter, actually is given in that paper as well, but they did a study with like considering different situation. For example, let us say that so initially they consider load loss, that means like I think 50 megawatt of the load, actually they are disconnected, and when load disconnected, you expect that the frequency is going to rise, right. And here also they are, because in USA frequency 60 hertz, frequency have rise, but the thing is like that they did consider that without any electrolyzer, and then considering like 0% DR, 25% DR. So, again what it says that EL frequency response. So, what is it does, you have designed a control that when the frequency changes, your electrolyzer will respond. But if you do not have any control that with frequency the power coming to the electrolyzer, then actually it will not respond like that. So, here they do have that frequency response service, and then they consider like different level of DR, like is it 0%, 25%, and also 50% in both cases, with and without electrolyzer. And they, for example, let us say if you have got 50% DR with an without electrolyzer, what frequency reduction it can make. Same for like if you have got 25%, like what sort of frequency regulation actually you can provide. So, here both like in one cases load gain, and if you load gain, then you will also find that frequency gonna decrease, but again like the similar things, like when it is rise, the service that is provided, when it is lost, can they provide like a similar sort of service. And again, so when the load losses, that means what electrolyzer gonna do? It gonna reduce the power taken from the grid. That's how it responds, right? And with the load gain, more load coming to the it will be in a opposite way. When the load demand rise, they are gonna reduce the input power. So, that's how the generation and balance will demand, right? And in other cases it is actually opposite. So, again this all the service is happening by only changing the input power coming to the electrolyzer, because you have got the control that when the frequency changes, the power taken by the electrolyzer will change accordingly. And this one, like what about if you have not load change, but if you have got, let us say, like a temporary fault, it could be that for a certain period of time, you have got either short circuit or whatever, and then the the fault is removed, then how the system is responding, again quite similar percentage. So, the reason they did that, because they want to understand exactly, like when they are going to implement in the system, like how much service it provide, and then what sort of technology they need, what sort of control probably they can provide, and so on. Anyway, I have got actually 2 more example, but I think again probably I will just skip due to the time limit. So, this is like one of the project that we just started in our university. It is given like the objective mostly like controlling voltage frequency, and then we did get some result, but here just only one thing that we did 2 sort of simulation when you have got like the instability itself in the generator. So, the generator is actually have got the transient stability problem. So, here you can see that you have got 3 generator, like so one of the electrolyzer is close to that. So, what happened when there is a fault, this generator become unstable. So, this electrolyzer it means to provide it bring back to stability, but it could not remove the frequency oscillation from the system. So, what it means that you need additional control with the electrolyzer. So, only electrolyzer is not enough to remove all problem that you might have in the system. So, like how we design those sort of control, and when you have got also like here the problems that we found in one of the Australian system, that during very sunny days, due to the power coming from photovoltaic system, they got like the over voltage problem. So, by using electrolyzer, we could see that how we could remove that problem, and using what sort of electrolyzer, what margin of the voltage they can actually change in the system. Yeah, and also I did have one example with MPC controller as well, but I'll leave it to for you to read and see. All the step is also given. If any of want to, we all also discussed in the previous class as well, but it showed that in certain condition, both the combination of droop control and MPPC, it can actually provide better performance. So, it does compare with many cases like the PID and then virtual inertia control, and also the MPC in the secondary level or the primary level in the droop, and then it compare like which one provides. So, definitely the MPC and the combination of the droop, it found that it can actually provide better performance when you have got the large disturbance in the system. So, yeah, so these are the some of the again like the challenges and more opportunities probably. Again, I mean, if you really want to work in this area, you can have this slide and see that where actually you can contribute, and then you can also, I mean, interested, I mean, you can develop some project and go on from there. And as I said like previously, I'm always more than happy. This is all the like the last day, but it's not the last day for our contact. You can contact anytime later as well. I'll be happy, very happy to give whatever recommendation I can give it from my experience. Thank you.
So we'll keep the question after the next lecture. We'll take 5 minutes quick break and we'll start the next one.